This is Mr. Waters again, and here's another example for page 642. And in this case, the information, it's a little bit different. We're going to be given the equation of the ellipse, and we're supposed to find the vertices and the foci of each equation, and then we're supposed to graph it. Well, let's say that we're given this equation right here. It's going to be x squared plus 7y squared is equal to 49. Well, we know that in order to graph it, to figure out the information that we want, the vertices and the foci, we are going to put the equation in, it has to be in the standard vertex form. Now that's going to be something like x squared over a squared plus y squared over b squared is equal to 1. That would be for a horizontal one, or if it was vertical, the b squared would be here and the a squared would be there. Okay? Either way, we won't know that until we've finished simplifying it and we've put it in that form. What we're going to do is we can see that in vertex form it has to be equal to 1. So I'm going to divide both sides by 49 to make it equal to 1. Right? So what do we get? Well, over here we get x squared over 49 plus the 7 cancels out and we get a 7 on the bottom, and we've got y squared over the 7 is equal to 1. Okay, so there we go. There, it looks like that's in vertex form. Okay, there's no coefficients on the x squared and the y squared, and the constant over on the right side of the equation is equal to 1. Well, we can see that the larger number is under the x squared. Okay, so that has to be the a squared. So right now we can see that a squared is equal to 49. The other number, b squared, has to be equal to 7. Okay, so that means that a, which is going to give us the major axis, which will give us the vertices in the major axis direction, that's going to be 7. And b is the square root of 7, which, according to my calculator, is going to be just about 2.6. So that is just about 2.6. So that gives us the distance in the minor axis direction. Okay, so let's go ahead and begin to kind of sketch this out. All right. So that's going to give us the vertices that we want. Okay, actually, let's go ahead and sketch it over. Draw the sketch over here. I wish I could draw a straight line. There it is. Like that. Now we're going to skip. That'll be 1, that'll be 2, that'll be 3, that'll be 1, that'll be 2, that'll be 3, and so on. Okay? So, now we can see from the form of the equation that the h and the k up on the top, the hk, which is the center point, that's 0, 0. So the center is going to be at the origin. And we can see that it's, like I said, horizontally oriented. So we're going to go 1, 2, 3, 4, 5, 6, 7 in the horizontal direction. And then over here, 1, 2, 3, 4, 5, 6, 7 in the other horizontal direction. So this is going to be one vertex on the major axis direction. This is going to be the other vertex in the major axis direction from the center, because it's 7 units over. Okay, so we can actually label those right off. That's 7, 0, and this is going to be -7, 0. Now the major or the minor axis distance is the square root of 7, which is about 2.6, which is about up here and about down right there. Okay, and we will label those 0, rad 7 to give the exact value, and then 0, negative rad 7 down on the bottom side. And we can now just go ahead and sketch in our ellipse like that. I'm sure yours will be much neater, but it's going to look something like that. And don't forget, we're labeling each of the vertices with coordinates. Okay, now all we have to do left is now we just have to figure out the C, which is the focal distance. Well, we're going to use our handy-dandy formula. C squared is equal to A squared minus B squared. A squared is 49. B squared is 7. So C squared is 42. C is equal to the square root of 42. And according to Mr. Calculator, rad 42 is about 6.4 or 6.5 rounded off to one decimal place. So there it is. Now, since it's a horizontally oriented parabola, that's going to be on the horizontally arranged between the two major axes. So 6.4 about there, negative 6.4 about right there. So the coordinates we will write as rad 42, 0 for that focal point, and for this focal point, negative rad 42, comma, 0. So there we go. We found the vertices in the major and the minor axis directions. We've found the foci, and we've graphed them, and we've named the coordinates of each of those points. And we've presented a graph as well. So that's all we need to do.